Good morning. Today we are going to discuss the Sharp Variable Speed Milling Machine and its various components. Starting at the top of the machine, we'll find the headstock or J-head. From our current view of the J-head, we can see the top of the drawbar, RPM selector lever, high gear, low gear selector lever, and the quill feed engagement lever. The drawbar is used to hold our 8 taper collets and other tooling in the spindle. The drawbar is threaded 7/16 by 20. Our 8 taper collets come in a variety of sizes. They are designed to hold various sizes of end mills, drill chucks, boring heads, and slitting and grooving tools. You will find a slot machined into the side of the R8 collets. This slot is used in conjunction with a guide screw inside of the spindle. This guide screw prevents the collet from spinning inside of the spindle. When placing a collet into the spindle, the operator should take care to ensure that the slot and guide screw are properly aligned. Failure to do so can cause damage to the collet, spindle, or both. Next, we have the RPM selector knob. This is located on the right side of the J-head as you are facing the mill. Please note the warning sticker on the RPM selector knob. Never attempt to change RPMs if the spindle is not turned on. Failure to follow these directions can cause damage to the mill. Directly to your front, you will see the RPM gauge. The outer ring of the gauge is used when the mill is in low gear. The inner ring is used when the mill is in high gear. The high gear, low gear selector knob. You change between high gear or low gear by pressing the lever slightly towards the body of the mill and then rotating the lever towards the back of the mill until it locks into place. Failure to ensure the lever locks into place will cause the gears to grind and a very loud reply from everyone in the shop to put it in dang gear. Up next is the quill feed engagement lever. This is used when performing boring operations on the mill or when a steady downward feed rate is desired for precision or accuracy. Ensure that the quill feed lever is disengaged when performing regular milling operations. Shortly, we will discuss a few other knobs and levers used when performing boring operations. The quill speed knob is located on the left side of the J-head as you are facing the mill. The speed settings are high feed, medium feed, and low feed. The quill activation lever. When facing the mill, if you pull the quill activation lever to the left, it will engage the quill feed in the downward direction. The spindle brake is located on the left side of the headstock as you are facing the mill. You use this lever to stop spindle rotation when turning the mill off or to keep the spindle from turning when tightening tools into the spindle with the drawbar and an R8 collet. The forward off, reverse switch is also located on the left side of the headstock slightly above and behind the spindle brake lever. On our mills in the shop, if the mill is in high gear, when you turn the power switch to the forward position, the spindle will turn in a counterclockwise direction. If you turn the switch to the reverse position, the spindle will turn in a clockwise direction. The opposite is true if the mill is in low gear. By placing the power switch in the forward position, the spindle will turn in a clockwise direction, and if the power switch is turned to reverse, the spindle will turn in a counterclockwise direction. Anytime you are changing gears on the mill, it is always a wise idea to ensure the cutting tool is turning in the right direction prior to engaging the tool with the material you are cutting. Failure to do so will cause damage to the cutting tool and potentially ruin your part. The quill feed lever, pictured with the yellow arrows, is used for drilling or countersinking operations on the mill. When using this lever, ensure that the quill lock lever, pictured with the red arrows, is disengaged. Failure to do so can cause damage to the quill. When performing normal milling operations on the mill, the quill should be in the full upright position with the quill lock lever fully engaged. Failure to ensure the quill lock lever is engaged during milling operations will cause the end mill to gradually feed deeper into the material, causing the material to taper. We are going to briefly touch on the tram bolts for the head of the mill. In the following pictures, you will see 4 tram bolts called out with yellow arrows. To tram the head around the B-axis of rotation, you will loosen those 4 bolts, leaving them slightly snug. By turning the tram bolt pictured in red, you will cause the head of the mill to turn on the B-axis. The goal is to make the head of the mill perpendicular to the face of the table pictured in the last. After tramming the spindle in the B-axis, your next step will be to tram the spindle in the A-axis. You will begin by loosening 6 nuts pictured with red arrows. As before, you will slightly loosen these nuts, then you will proceed to turn the tram adjusting nut pictured in yellow and red respectively. The goal is to make the spindle perpendicular to the table as shown in the last picture. Once both axes are trammed perpendicular, You will proceed to tighten all tram nuts until they are tight, periodically checking the tram of the spindle to ensure it is still perpendicular to the table within 5/10 or 1/1000 of an inch. We will cover fully how to tram the spindle in another video. Up next is the table. Here you will find the vise or other fixtures for mounting of material. Attached to the table are table stops, table feed handles on each end of the table, and on our machines you will find an auto-traverse mechanism mounted to the right side of the table as you are facing the mill. One full rotation of the table feed handles will move the table 200,000ths of an inch. Pictured here is the saddle of the mill. Attached to the saddle are the X-axis locks with yellow arrows and the sensor for the X-axis table stops with the red arrow. To the left of the saddle, as we are looking at the picture without an arrow, is the Y-axis table lock. The knee of the mill is responsible for raising and lowering the work table in the Z-axis. The knee is identified by the red arrow in the picture. The knee height is raised and lowered by use of the knee height adjustment handle identified with the orange arrow. One full rotation of the handle will raise or lower the knee 100,000ths of an inch. The green arrow identifies the Y-axis feed handle. One full rotation of the feed handle will move the table 200,000ths of an inch. To the left of the knee as you are facing the mill is the oiler. The oiler is responsible for oiling the saddle, knee, and lead screws. You should give the oiler 3 to 5 pumps daily when using the mill. In this picture, we have on the right side partially in view the oiler. In the middle of the picture we see 2 silver handles. These handles are the knee locks. When engaged, they prevent the knee from moving up or down in the Z-axis. At the bottom of this picture we have the foot or base of the mill. The foot of the mill holds the lead screw for the knee and the column of the mill. The last picture is the column. At the top of the column is the turret, which we will discuss in the next section. The turret allows for rotation of the ram 160 degrees in either direction. To rotate the turret, loosen the 4 nuts, 2 in each picture. Rotate to the desired angle and then retighten the nuts. Last, we have the ram. Adjusting the ram allows us to mill larger pieces of material than the Y-axis movement allows for normally. To adjust the ram, we loosen the 2 levers in the last picture. Once loosened, we can move the ram towards the operator or away from the operator by use of the large handle in the middle of the locking levers. Okay, now that we have covered the components of the mill, we will go over edge finding and setting the DRO. I set the RPMs of the mill between 750 to 1000 RPMs. I am using an edge finder that has a 200,000ths end, so the offset will be 100,000ths. I feed the edge finder into the edge of the material until the tip breaks center. The edge of the material I am edge finding is the bottom left corner, so the Y-axis offset will be negative 100,000ths of an inch. Once I have finished with the Y-axis, I will move to the X-axis and repeat the process until I have completed edge finding and established my X and Y zero.
Now that I have established my X and Y zero, it is time for me to square up my material. I am using a 3/4 inch high speed steel end mill with 4 flutes. I have placed the shank of the end mill all the way into the collet, stopping just before the flutes. This is the best practice anytime you are milling. I am milling 6061 aluminum, so I'll use 500 surface feet a minute to calculate my RPMs, which comes out to just over 2500 RPMs. Using 2500 RPMs, 2007-inch feed per tooth, and 4 teeth on the end mill, I calculated a feed rate of 20 inches a minute. Remember, never adjust the mill's RPMs unless the spindle is turning. With the spindle running and my RPM set, I will feed my end mill over the bottom left corner of my material with approximately half of the end mill over the material. I will then raise the knee slowly until I barely contact the material. I will then move the end mill off the material, raise the knee 25 thousandths of an inch, and set the dial on the knee to 0. By doing this, I have established my Z0 for the part. Now I can face the top of my material, leaving a machine surface. Remember, never climb mill on a manual mill. You always want to conventional mill. Once I have milled the top face of the material, I will deburr the edges, rotate my part, and machine the other surfaces until I have a squared up piece of material.